welcome back to my channel. So today in this video we will be learning about binary search. So after completing our sorting techniques, here we are moving to a binary search. Linear search is also very important search, but it is not much widely used because due to its efficiency. But binary search is way more better than linear search. So I'll explain you binary search. In linear search, it's just a for loop and you'll find the element quickly. The thing is, you need to traverse the whole array to find the element. That is the most important drawback of linear search. If you want lecture for the linear search, comment down, I'll provide you the video for that. But for now, as binary search is more important than linear search, I have started with binary search. So as I said, the disadvantage is to find out any element which is present in linear search, you need to traverse the whole array. So therefore its time complexity, space complexity will always be way more greater, right? It might be big of n square or something like that. Therefore we'll always prefer binary search instead of linear search. So what we'll do in binary search which overcomes the disadvantage of linear search is, the very first thing is, you are not traversing the whole array. For example, just take an example. Here my target, this is a given array, this is a sample array which I've taken a sorted array. Okay, that makes the explanation and understanding way more easier. Therefore we will start with taking the sorted array. You have already watched the previous videos, therefore I don't need to explain how sorting all works. So if you didn't watch, go back and watch all the sorting techniques. Whichever you feel comfortable, you can go through it, right? So after sorting, what can you do is, you need to find out the key element which is present in the array. Now what we'll do, instead of traversing the whole array, what can be done? A small trick, can you think of it? Pause the video if you don't more time, or if you have the answer, comment down. Now I'll share the answer. Say for example, if my target element is 31, this is my target element, and if I want to find out this target element in linear search, what happens is, I'll say first, is first element is equal to 31? No. Is the second element equal to 31? No. Is this equal to 31? No. So you need to traverse till you come for the seventh position of the array, right? So here you're not doing that. What do? You will divide the array. How do you divide? I'll mark this as low, that is the first index will be marked as low, and the last index I'll mark it as high. Fine, this is my last index, and I'll take a middle element, that is low, this is the low, right? The low and high plus 2, sorry, divided by 2. So what happens is 0 plus 8 by 2 will be my fourth, that is this index. So fourth index is my middle element. I'll mark it as M. Yeah, so this is how I'll divide the array. Now I'll check that my target element is 31, right? Is 31 less than middle element? Is 31, hmm, I'll take some lighter color. Is 31 less than 15? No, right? It's wrong. You can't do this. Therefore, what you'll do, you'll not at all see the left part of the array. You don't want to see, because it's already sorted, right? You don't want to see this part of the array. And now you understood that it is greater than middle element or might be equal to middle element. Now I'll see my second condition is 31 greater than 15? Is 31 greater than 15? Yes, it's true. So what I'll do, I'll traverse only towards the right side of the array. I'm not at all seeing the left side of the array of the middle element. So here I can traverse. I hope you understood how we are doing. So what is the definition of binary search? Binary search is one of the searching technique which reduces the search space into half. So instead of traversing the whole array, you're actually reducing half of the array. You're not wasting the time in searching the half of the array. You're only concentrating only on this part of the array, right? So after you do that, you understood that you're going towards your right side of the array. But going to the right side of the array, then what I'll do? Should I again traverse one by one? No, again it will be complicated, right? Traversing one by one is always complicated. So what we'll do is, again we'll take this low, high, middle technique. I'll remove all this. So now you have understood that your target element is right side to your middle element. This is my middle element, right? So we'll start from here. Now we'll make sure that we'll change this. Now my low, middle and high position will be changed after you're getting know which side of the array you're going to. So before that, where was my low? Here was my low, here was my mid, and here was my high, right? This was the initial condition. But after you getting know that your target element is right side towards your array, what you'll do? For now, the array, the mid, this element, that is 15, middle element is less than target element, right? So if you find out your middle element is less than target element, what can you do is you have to change your low to mid plus 1. That is, you are making sure that low is coming over here. So here will be my low, here will be my high. High will be at the same place, okay? High will be same place. Again, you'll change your mid position. If this is your low, if this is your high, the middle has to be between low and high, right? I'll change the color for your better understanding. Yeah. See, this is my low, this is my high. So your mid has to be between low and high. So low index value is 5 and high is 8, right? So 8 plus 5 is the middle element, what you get, 8. So that is 8 plus 5, 13 by 2. 13 by 2 will be 3.5, which you can round it to 6. 13 by 2 is 6.5, you'll round it to 6. Fine. I'll remove this. This is my new low, this is the new high, and after taking out L plus H by 2, your middle will be 6. This will be my middle element, okay? Now you will see, again same condition you will see. Is my middle element less than target element? Yes, true. If it is less than, again you will traverse towards the right. But if it is greater, if the middle element is greater than your target, example, if my target was 20, 20 is less than 25. Therefore, you will traverse towards the left side of this array. But now your target is greater than the target element. Therefore, you will traverse towards the right side. Fine. So again your condition comes. Again in this array also you will make a cut. How do you cut? Again you will change this low and high position. Again the same condition here. My middle element, this middle element is less than target element. So what did we do? We'll change our position, low position to mid plus 1. That is middle plus 1. So this is my middle. I'll change this low element over here, and again my L comes here. So this is removed now. I'll just erase this. This is nowhere present. My middle is also changed. Now this is my new low and high. Again you can calculate your middle. 8 plus 7, 15. 15 by 2 will be around 7 by, sorry, that is 7.5, which will be 7. Again your middle elements comes over here. Now you see, is my middle element is equal to target element? Yes, that's all. You can come out of the loop and you got your answer. My middle element is my answer. You found out your key. If it is not there, you do this all the way throughout your array and you don't find it, and you can just simply print not found. These are the 3 conditions which we are doing. I'll just show you. So the first step is, if the middle element is found, I'll remove all this. Give me a second. See, the first condition is if your target is middle, then we found out the element. But if it is not middle, if the element is less than middle element, you will traverse towards the left side of the array. And if it is greater, you don't traverse towards the left side, but you only traverse towards the right side of the array. That's all. Very simple, right? So this is how the 3 condition which will which we'll use in our binary search. So let's code this and show you. So let's start. I'll remove all this. Can we increase this? Yeah. So first I'll initialize the array. Int array is equal to, let me take some basic simple example. Okay, fine. Now I'll initialize target. Which target shall I take? Shall I take 2? Fine. Because in the example I have understood the greater element better than the middle element, right? So I'll be taking lesser element which is compared with middle element. So I have taken 2, and then we'll initialize low. We'll initialize low 0 because we are setting it to the 0th index of the array. And high, we'll set it to last, that is array dot length minus 1, that is the last element. And now we'll make sure we'll have a boolean flag, that is boolean flag is equal to false. First we'll initialize it to false, and if it is true, at the end we'll print it, right? Now after boolean you'll check while low is less than equal to high. If it is a condition, see, in all our examples which we had taken, always the low is always less than high. So that's what the condition. You can use any for loops also, but while loop is way more easier for me to understand. Next we'll initialize mid. What was the mid formula? Int mid is equals to, sorry, low plus high divided by 2. This was a formula, and we'll go with the conditions now. If first I'll give a this only condition, that is if array of mid is equal to target. If it is equal to target, you can directly break it, that is you can initialize flags equals to true first, and then you can break the loop itself. Fine. If it is not that condition, you can go else if condition. In else if, array of mid is greater than the target. If it is greater than the target, what you do? You'll make sure your high, if the middle element is only greater than the target, you'll make sure your high will come this side. See here, if you're going towards the left side of the array, here was my high in the first condition, right, in the first step. But if your target element is between the left side of the array, what you'll make sure, your low will be here only. Low will always remain here. High will come this side. So where does the high comes? High should come at the middle plus 1. High should come here. But if the element is towards the right side, your high will remain here and your low will come towards this side. Fine. Sorry, here comes my high, not here. That is here. Fine. So that's how we'll code here also. That is high is equal to mid minus 1. Else if, again you will write the same condition but different if condition. If your target is higher, you'll make sure that low comes to mid plus 1. You understood these two lines, what we are doing here? High is equal to mid minus 1 and low is equal to mid plus 1. As I said, if you're going towards the left side of the subarray, you are changing I position. But if you're going towards the right side of the array, you will be changing low position. Okay, that's the simple funda which you need to remember. So after this, your code is almost done. You can print it if it is found, that by using flag obviously. You can write if flag is equal to true. If it is true, you can directly print system.out.print found. Fine. If it is true, else you can print not found. Yes, let's run this. Oh, there is some error. Else. Okay. We shall use the braces for that condition. And now let's run. I hope no error. Again, why? Else if. Okay, we shall give here the brackets. See, braces brackets are very important. So don't forget. See, you can see the code give the successful execution that is found. For example, I'll change the target to 25 and let's run now. It has to print not found. See, not found. And if your array is something is not sorted, you can directly use arrays.sort array or arr or nums, whatever you give the array name. So you can first sort it and then you can make sure your binary search code run. That's all, guys. Very simple. I hope you understood how the working of binary search happens. So thank you for watching till now. Bye.